formula based on how fast you're going, how far your car will continue to keep moving before you hit a stop, assuming that your brakes are also in excellent or average condition. Because if your brakes are worse, you're going to probably skid more and whatnot. So let's go ahead and I went ahead and typed in this equation into my calculator, and using the table values, I went ahead and got all the values I needed. So there's no reason why these questions can't have exact answers. The graph gives me good estimates, but the table in the calculator gives me more precise measurements. So I'll go ahead and rely on the table for my answers to my questions. I went ahead and added some parts to the graph. It says speed in miles. I went ahead and added miles per hour, because this is the velocity we're measuring down here. So it's in miles per hour or in mph. So question B, once again, just break down the graph. What is the independent variable? The independent variable is always your x-axis, so it's measuring the speed in miles per hour, which I should add here. Part C, what does the dependent variable represent? Our distance in feet. That's how far you're going to keep skidding, in other words. You can add those details if you feel obligated to. Part D, what is the stopping distance if someone is driving 15 miles an hour? Well, according to our table and the table in our calculator, our stopping distance will be 27.75 feet. And that's exactly what I wrote in the sentence. Part E, what is the stopping distance if someone is driving at 40 miles per hour? According to our table, it'll take them 124 feet before they get to a stop. Another way you can say the same thing. Part F, if the stopping distance is 100 feet, how fast is the car traveling? So we have to work backwards. I don't have an exact value for 100, but I can get pretty darn close right here. So I went ahead and approximated. 99.75 is the distance, the stopping distance, and that occurs at about 35 miles per hour. So I went ahead and said when the car is traveling about 35 miles per hour, because it's an approximation, it's not the exact amount. And then for part G and H, notice I put two little asterisks, and there's a reason why. First of all, it says, what is the reasonable domain? Well, if I go by the graph, notice there's no stopping point on the graph, so I could say the domain is all real numbers greater than 0, which is what I wrote here in equation form. And then the height, or the range, would be everything from 0 infinitely upwards also, and that would be from y, except that would be all real numbers greater than 0 also, which I would write in this form. But this is a real world scenario, and we don't have cars that can go infinite speeds to give us the infinite distance in feet. So I put little stars next to it. Most other questions will probably be worded a little better, but for all, just for the sake of argument, we'll say our domain is all real numbers greater than 0, because this graph is going to keep spreading to the right infinitely if you give it enough time. So that's why this answer is valid, and so is this one, just based on the graph alone. And then finally, we're asked to write a conclusion about what we can see in the relationship between speed and distance that it takes from a driver to stop. So basically what we saw on the graph is the greater the speed your car is traveling, the greater the distance it's going to take for you to stop, which is very intuitive and kind of common knowledge, common sense. So just make sure when you answer these questions, try to use complete sentences as best as you can. And I recommend even taking the exact phrases from the sentences. Makes you sound smarter and cuts your work in half. All right, so good luck with this assignment, and see you guys later.